Hi everyone, I'm excited to see you here. I hope that many of you have heard the previous talk. It was also about software updates. If not, please see the slides afterwards and the video. I will talk about a bit different methods of software updating software, namely of OSTree and of our meta updater layer that integrates OSTree into Yocto Open Embedded build process. So I work for a company called ATS. Okay. Okay. What do we see here? It's fine, yeah. Sorry for that. So I work for a company called ATS. Our main field of expertise is, unsurprisingly, software updates for embedded systems, namely for automotive systems, but not only for automotive systems. And until recently, our only concern was secure and robust delivery of update to the target device. But with the launch of our open product for web service for updating any IoT device over there, over wireless or wired network, we decided that it's important to care about what we actually deliver to the device, how we actually update them. And we integrated OSTree repository into our ATS garage. So those who heard the previous talk, I hope you are already convinced that we need software updates. I will just say that it is apart from security and market concerns, it's actually really convenient with regard to CI process for, I think, everyone who tried to make CI on embedded devices were really tired with this continuous refreshing all the devices. You need to get physical access to them, and it's really cool to do it over the air. And until recently, we had so now as of now we have basically three methods of delivering updates. First is package-based, what we use in all our desktop or server Linux distributions. It's nice, so it's convenient. We only download what we want to download. That's very important for over-the-air updates where bandwidth is expensive. But it's not fit for embedded systems because we don't have a human operator. Like if we are stuck, if our package is not compatible with another package, or we install two packages that are mutually dependent and our installation breaks in between, we can't recover from that. So what the guy, Enrico, was talking about is that it is, for embedded systems, it is good to have full file system update when we just download the full file system, flash the backup partition, and we're done. We can test it exhaustively in our development process and deliver to our client what is definitely working. But it also means that we have to download the whole file system image, which can be hundreds of megabytes, and our bandwidth is slow, unreliable, and our customer is going to pay for it, and he wouldn't be happy with that. So OSTree, with OSTree you can deploy virtual bootable file systems, but you only download what you have to download. The difference between two file systems, not the whole file system. So a pair of words about OSTree itself. It was not developed by ATS, it was not developed by me, of course. I had made a pull request once and it was declined, but it's developed by Colin Walters, a Red Hat developer, and it was not intended for embedded systems. Its original purpose was continuous integration for GNOME team. You can get more info there. There will be links, of course, in the end. And basically, a typical memory device of OSTree-enabled system looks like that. You have this small boot partition with U-boot configuration, and you have so-called physical sysroot, which is surprisingly not bootable, but it contains OSTree repo. I forgot to tell you that OSTree, that was on the previous slide, OSTree is a Git-like tool. So who knows how Git works? We basically have our object database or sets of objects that are addressed by their hashes. We see file objects, directory objects. We don't see any commit objects, but there are commit objects, believe me. So yes. So in our physical sysroot, we have this object repo. We have several one or more deployment sysroots, and we have some information for bootloader so that bootloader knows which sysroot we are booting into. And the order of the boot order when we start our device, bootloader reads first it reads some decent info which is inside it. Then it reads our info that OSTree provided to him, which is stored in /boot/loader in physical sysroot. And then it gives control to initramfs, which uses power of Linux environment to prepare all the complex stuff. I will talk a bit about why do we need to do this complex stuff, why we need to remount user and all this. Yeah. It's a bit more detailed view of this physical sysroot. There are a lot of lines and errors, but what's important here is that our deployment sysroot basically files in our deployment sysroot are not duplicated. They are just hard links to objects in our OSTree repo. That means that we don't have to have repo and then one deployment and then another deployment. We don't have to duplicate all the data. We just store what we need to store. And from what I've said so far, it's maybe self-evident that to adopt this OSTree, we need to prepare physical sysroot. We need to prepare deployment sysroot. We need to make bootloader and initramfs work together to do this loading process. And the good news is that if you use Yocto, if you use Open Embedded, you can just download our meta updater layer that is already implements all this complex stuff. But you can't just take your rootfed that you are using right now, maybe because there is another concern about mutable state in our system. So what is mutable state and why we should care of it? As I said, files in deployed sysroots are just hard links, and they're shared between sysroots. It means that we can't really write to these files, because if we modify them, we first break abstraction of independent sysroots for independent file systems, and second, we break our repository, which contains hashes of all the files and all this stuff. So if we want our data to be managed by OSTree, we need to store it in a read-only part, and all the read-only data in OSTree should be stored under user/user partition. And we also can have /var directory, which are, as we can see, it is shared between the deployments. Here's deployment 1, deployment 2, and here's var that is shared between them. And of course, it's not updated by OSTree. It's written in runtime and read in runtime. Well, yeah, and there's another read-write directory called etc. There is some problems with that. I will talk about it later. So there is a meta update was originally developed for AGL that is automotive grade Linux. It's a Yocto-based distribution for automotive devices. And there was a very typical scenario when we should care about our mutable state. In OSTree or in AGL, apart from full file system updates with OSTree, there is also so-called application framework, which is basically it's basically a sandbox for applications, much like what we have in Android, and it can install applications in runtime, and of course it has some database for it which should be writable. And the interesting part of it is that some applications can be already pre-installed with our file systems, while others can be installed in runtime. So there is a kind of a conflict between two update domains. When we perform our OSTree update, what we should do, and when we boot first time, what we should do. There are three ways of solving this problem, not only for AGL, but also for, well, every time we encounter this problem, there are three options. We can just ignore what's in initial database, what's in var, and actually it's what meta updater does by default. It's same default option. It will give you a warning, of course, because if you have something in var, that probably means that you have missed something, that you forgot about some mutable state in your system. But it was really not an option in AGL, not because, yeah, of course we can say no pre-installed apps, no problems, but due to some technical issues with access rights, we needed to deploy it. We couldn't deploy it in runtime because we needed to set the access rights in SMAC, which is a tricky access rights manager in Linux. Another option, what maybe application developers would want, is to have a smart merger process that will merge what we have in our full file system update with what we have installed in runtime. And it's actually approximately was what OSTree tries to do with etc. And the problem with it is the same as with package-based update, that we don't have a human operator, and if our merger process produces something inconsistent which breaks our system, we're stuck. We can't do anything. And a moderately dumb solution is to just populate, have our initial database in our OSTree deployment and just populate it once on a startup. That way we can't update our applications with OSTree, but we can at least update them with application framework, and we can at least have an initial set of installed applications. So meta updater, for those of you who are familiar with Yocto and Open Embedded, it's Yocto Open Embedded layer. It's integrated seamlessly. You can just add it to your bblayers.conf. You can include distro include or use our distro file and just type bitbake, whatever your image name is, and you get an OSTree commit as a resulting image. You have a bootable sysroot as a result, and optionally you can push all your newly created commit to some server which has a well-documented open protocol and is by pure chance implemented by our ATS garage. Of course, it doesn't implement what I was talking just right now about population of /var, because it's really application dependent, and it has a number of supported boards. But of course, if you want your board or your bootloader, you need to write some not so large integration layer. And if you do, please inform us. We really want to support as many boards as possible. And yeah, I just wanted to warn about some problems that are still present with this. There is a problem with default etc merger. What OSTree does, it tries to merge when you update the file system. It tries to merge your new /etc with what you already have. And well, sometimes it breaks. So maybe for embedded systems it will be nicer to just take etc as it is. Second is compared to dual bank system that Enrico was talking about. Physically there is only one file system, and if because of some hardware issue or driver issue or whatever, or combination of different factors, it breaks, it's broken. You can, of course, have a boot backup partition, but you lose then benefit of economy of disk space, but you don't lose economy of bandwidth consumption. So third, well, a serious issue that when you deploy it in production, of course, you can test OSTree before deploying, but in CI, you frequently run into a situation when you update OSTree and you break it and you can't update your system anymore because OSTree is a part of your deployed system, which is funny. And if you want rollback, you need to, it's not responsibility of OSTree. OSTree will just download whatever data you need, it will deploy it. It will tell bootloader that next you should boot your newly deployed system. But if you want rollback, you need to define, well, you need a definition of failure, and you need to recognize failure and switch back. And ideally, it should be done in bootloader or some, yeah. So yeah, here are a number of pair of links. OSTree itself, please, you can look into details. Fortunately, with our meta update layer, won't need much of details of OSTree. Here's website of automotive grade Linux. Well, meta updater was initially implemented for AGL, and it's called meta SOTA there. And you can also try it out, download AGL, build it with Yocto, bitbake, and get a ready-made OSTree-enabled file system. If you already have your Yocto project, please look at meta update layer itself. It's pretty straightforward for adding it to your build system, just as you add any other layer. And for those of you who are unfamiliar with Yocto, with Open Embedded, please try out our quick start, which is basically, well, it's quick start for Yocto and meta updater. It has Pokey, it has meta updater, it has meta Raspberry Pi. It has nice tutorial, step by step. You can walk it step by step, and quickly have your OSTree enabled Yocto build system for Raspberry Pi. So that was it. Questions, please.